Hi, my name is Caroline Hughes. I am an energy data and simulation analyst with the U.S. National Renewable Energy Laboratory in Golden, Colorado, and I'm extremely excited to be presenting at JuliaCon 2020. Within NREL's Strategic Energy Analysis Center, we consider the broader impacts of energy decisions. The SLiDE.jl package aims to expand analysis to consider economic impacts of these decisions. After some COVID-related delays, we're still waiting to open source the SLiDE package. It will be available on GitHub after internal code reviews. If you would like advanced access, please contact us and we can set that up for you. I am co-developing SLiDE with Maxwell Brown, who is a brilliant CGE modeler and the fearless leader of our project on Expanding the Scope, a model for intersectoral and economy-wide impact analysis. My background is not in economics, but in nuclear engineering. I came to NREL a little over a year ago because I really just want to solve challenging and interesting problems. So I sincerely appreciate Max for bringing me onto this project to handle the data management and processing for SLiDE. We as a team are extremely grateful to the Wisconsin National Data Consortium, particularly Thomas Rutherford, Andrew Shriver, Adam Christensen, and Gökçe Akınolkum. Their work on the WinDC dataset laid the groundwork for our project, and SLiDE would not be possible without it. NREL has a myriad of energy modeling tools co-developed by modelers and data scientists. However, none of these tools consider the economic implications of energy decisions. With our work, we seek to remove the overly simplistic and static assumptions concerning economic boundary conditions by developing a model of the economy and coupling that model with detailed engineering-focused energy system models. To maintain compatibility with other NREL models, we have developed our model using the Julia programming language. By doing so, we also hope to encourage broader adoption of Julia within this particular modeling community. SLiDE is being developed under the Scalable Integrated Infrastructure Planning Initiative, which seeks to enable cross-communication between these models. And you can access the SIP platform at that GitHub link provided on this slide. So now on to SLiDE. Our goal is to use Blue Note, the dataset compiled by the Wisconsin National Data Consortium, to build an open source computable general equilibrium, or CGE model, for the SIP infrastructure in Julia. This model is scalable in region and sector. We can currently model 51 states plus Washington, D.C., and 73 sectors. This model will be linked under the SIP framework, connecting it with other models, including READS and Tempo, which are also developed at NREL. This model will be dynamic. Of course, it is a CGE model. WinDC's Blue Note dataset is generated using Python, and their original CGE model using this dataset uses the General Algebraic Modeling System, or GAMS, to implement their model. We are instead using JUMP. This poses some additional challenges as JUMP does not have some of GAMS' built-in compiling capabilities. Julia also lacks capabilities provided by GAMS' mathematical programming system for general equilibrium analysis framework for economic equilibrium modeling. Of course, there are also benefits, including SIP compatibility, speed, unique functionalities, including methods and structs, which we rely very heavily on for our work with SLiDE. And of course, there are benefits of using one language to both process all of the data and do the modeling. So this project and the process for developing the SLiDE model includes 4 steps. The first is data operations to prepare more Excel human readable data that looks nice in Excel to be useful in a model. Second comes calibration, and then sharing to divide national data regionally, and then of course the modeling. For this presentation, I will be focusing on the data operations. So here we will build on the WinDC data stream work, which was originally developed in Python. The original data processing includes hard-coded Python scripts for every data file, with several scripts required for each step. And this accomplishes things like cleaning the data and ensuring that the keys, such as sectoral and regional identifiers, are consistent across files. However, we can do this a little more succinctly using Julia. We do a couple things that were unique and innovative for the SLiDE package, including storing data operations in Julia types, and then performing these operations using general methods of SLiDE functions. This makes the data operation definitions user-friendly and human-readable, as these are described in YAML files, which help acquaint new users with Julia and get them up and running more quickly. So first, using the infrastructure systems package, we can define structs in a JSON file. And these structs can do things like add new columns to data or rename existing columns, etc. We'll get more into what these operations look like. So after we define these structs in a JSON file, we can run the function generate structs. And this will create a new file for every type of struct. Here we're looking at an example for renaming. And this type is creatively called rename. And it shows up in its own Julia file, as well as an includes file, which will make sure that add, drop, describe, all of these other types are exported in the SLiDE package. So finally, we can define data operations in YAML file definitions. And this makes our process much more user-friendly, allowing us to define a YAML file that looks like this for every set of data. And this can include multiple input files and standard definitions in types that describe these data operations that we're performing. Now, this is done with just a few helper functions that are part of the SLiDE package. One is load from, which will load data into one of the types as specified. And for example, this can work for all of the dictionary keys that are read in when the YAML file is loaded. And this can also work for data frames. And this works by looking at the field type that's defined in the struct and converting that entire column to that type and then storing that in the data type. And this will be extremely useful later on in SLiDE when we're looking at how to store a lot of data in those types that are useful for both modeling and then processing that data afterwards. So finally, we have our YAML definition file, and when this is read into Julia using our read file function, we end up getting a dictionary with keys that correspond to the operations defined as data types and lists of those operations in that type that will be performed. Now, since this does cut down on those hard-coded files, but it is still a little challenging when you're actually putting these YAML files together to have so many open at once. So we can define all of these as columns in a spreadsheet that will be read and used to generate all of these YAML files in just a few steps. And using this process makes it a lot easier when you're actually going through and editing, and when you want to compare the types of operations that are made during the data stream. We can really just look across the rows of the spreadsheet and see what we're doing. So again, one of our big goals here is usability, and this is definitely something that we have made great strides toward by using this process. So finally, I'm going to go through an example where we're going to look at the edit with function that has many different methods that take these different types and will perform these actions on this data frame. So here we're looking at actual data, or a little slice of it, from the National Agricultural Statistics Service. And here you can see there's a lot of extra data and extraneous information. We don't need to know that the period is a year. This is the same for all of the input data. So first we'll read in this file using the path in and path out defined. And these point to the location within the data sources, which contains all of the different data that is read into this model. And that will tell us what file to read and what descriptor maybe identifies this file if we're reading several different files and concatenating them together. So in this example, what we can first do is drop this extra information because it's taking up a lot of space in our memory and we really don't need it. So just with this line in our YAML file, we can define which columns we want to drop, the values that we want to drop, and the operation we want to use to perform this. So in Julia, this is read in as a list of all of these drop types, and then we can call the edit with function that says we're editing this data frame with these drop types. And after, we get this much simpler data frame. We can then rename these columns in the data frame to be consistent with the variables that we're using in the set names when we're performing the model. In the original processing in Python, this is done in several different steps, but here we just want to do this all together to make this easier, and so we can just see all of our definitions in one place. So again, here's our Julia translation, and we can apply that same edit with function, just a different method this time, and rename these columns. This now gets a little more complicated since we need to extract these NAICS classifications. And these are bits of data that are linked to this sector that is defined in for each of these agricultural statistics in the region R. Here we're using Wisconsin as an example, as an homage to the Wisconsin National Data Consortium as our region. But we want to get that sectoral information out here. So again, we can do the exact same thing. And so we'll get our match, apply that edit with function with this method. And then after, we just extract the NAICS classifications. We then want to add a column, and here we're adding a units column that says that all of these are in US dollars. So we're gonna add that here, again, exact same methodology. or applying that edit with function. And then this is where it gets a little more complicated, and we do have some mapping files that are used to map things like regions and units to be consistent with what we're using in SLiDE. So, for example, different data sets might reference Wisconsin differently, but we want to make sure this is all consistent. And we can also use this to convert units. Since different data sets come with different units, but we need to standardize these all here. So we can do that with mapping. And when we translate this into Julia, again, we get the list of maps that we want to apply. And again, using edit with, we get this finally. So we here want to convert this numerical value to 0. And I was able to ask someone with the National Agricultural Statistics Service what this D value means here, and that means that it was too small of a set size, or too small of a data set where it would have been identifying information. So it's just left as a D, so we can replace that with 0. Again, same method. And you'll see here there are some replace operations that aren't implemented here, and that's fine. We get that 0. Now, finally, we can use our unit conversion map that we read in to scale all of these values to be consistent units. So we can define this operate as a type, read it into Julia, and apply edit with to multiply those two columns together and change the units label from US dollars to millions of US dollars. Now we can save this extraneous information here. This is more for checking as we go, just to make sure this function is working the way that we want it to. So now we want to just save the relevant information, and we can do this by applying the order type of edit that will just save these columns in the specified order and make them of the data type specified here. So finally, we end up, after we, again, read that into Julia, apply edit with, we finally get this data frame. So in summary, you can see this was our input, and by using the SLiDE functionality, we got to this output here. So this is the same methodology is applied across all of the data sets. It's very standard, very straightforward if any user wants to make changes using that Excel document or writing their own YAML files. They can make those edits themselves and apply this same methodology to edit any data set. And this has been extremely helpful as data has been updated over the years. The same functionality is usually applied and the same formatting needs to be changed. So these same operations still apply, but even if they don't, it's still pretty easy to edit. So I'd now like to talk a little bit about my experience using Julia. I first started using Julia in grad school, maybe in 2017, as part of a class, and I've just been so floored and coming back to it now, the strides that have been made in really documenting everything really well, and that's made it much easier to learn and pick up really quickly. It's also really amazing all of the changes that have taken place in the language since then. It definitely felt different coming back to it a couple years later than it did back then, but in, I think, really great ways. I think it's easier to work with now than I remember it being, and I found that using Julia has allowed me to be a lot more creative with my programming and defining those different methods of different functions. I think it makes the programming much cleaner, and I think it has really great opportunities for doing really interesting things. So my presentation today has focused mainly on the data operations that produce the Blue Note dataset for SLiDE, and I haven't mentioned the model side of things. So to update you on what we've done so far, we have replicated the benchmark via the canonical Blue Note model and have added simple dynamics to that model. However, we still have a long way to go. Some of the things we'd like to include are capital vintaging, the flexible functional forms, which again is really simple and straightforward to do in MPSGE. That was the mathematical programming system for general equilibrium analysis framework, again, which is very straightforward to use and hasn't yet been implemented in JuliaCon. This is something that Max is working on, and he's described it as brutal. So this is definitely something that is a work in progress. We're also interested in a household disaggregation. Right now, we're working on the state and county level, but it'd be really interesting to see how energy decisions will impact different members of our communities based on information about their different households. We are also highly prioritizing model linkages for this project. In the original Blue Note dataset, we get a lot of energy data from the SEDS or other energy data sets. And what's really great about using other NREL models like reads is we can use those to predict out into the future what things will look like and really make predictions. Another thing that we would like to do is expand this from just a regional US model to include international representation via GTAP or another data source. So this project has definitely been really exciting and truly something I look forward to working on. And I really appreciate using Julia and all of the opportunities it's provided me as a language. So with that, I would like to thank you all for your attention and remind you that the SLiDE package will be available at github.com/nrel/slide. Again, if you want advanced access, please contact me at caroline.hughes@nrel.com, and also let me know, .gov, and also let me know if you have any additional questions. Thank you so much.